On May 1st, 2026, a camera that was never designed to take pictures of anything scientifically important produced one of the most detailed images ever captured of a very small, oddly shaped moon orbiting Jupiter, a world so obscure that most people have never even heard its name. The instrument responsible, called the Stellar Reference Unit, exists on NASA's Juno spacecraft purely to help the vehicle figure out which way it is pointed, snapping pictures of star fields so onboard computers can calculate the spacecraft's exact orientation in space. It was never built to produce scientific discoveries. And yet, for the second time in its extended mission, this navigation camera has just delivered a genuinely stunning, first-of-its-kind image, this time of a moon called Thebe, revealing details about Jupiter's faint, mysterious ring system that no instrument had ever managed to capture before. This is the story of how a spacecraft's backup navigation tool became one of the most productive scientific cameras currently operating anywhere in the outer solar system. And why the picture it just took has scientists genuinely excited about a part of Jupiter's system that almost nobody outside of planetary science has ever paid much attention to. To understand why this single image matters, you first need to understand what Thebe actually is, and why it has remained such a persistently difficult target for study. Thebe is the second largest of Jupiter's 4 small inner moons. The spacecraft launched from Cape Canaveral in August of 2011 and arrived at Jupiter in July of 2016, becoming, notably, the first solar-powered spacecraft ever sent to operate so far from the Sun, a genuinely significant engineering achievement in its own right, given how dramatically sunlight intensity drops off at Jupiter's distance compared to Earth's. Scott Bolton, the mission's principal investigator at the Southwest Research Institute, has described Juno's core purpose in memorable terms, calling Jupiter the Rosetta Stone of our entire solar system, and describing Juno's role as functioning like humanity's emissary, sent specifically to interpret whatever secrets Jupiter's deep interior and turbulent history might reveal about how our entire solar system originally formed. Juno completed its primary science mission in 2021, and rather than concluding operations at that point, NASA extended the mission, shifting its focus increasingly toward Jupiter's fascinating collection of moons and its faint, understudied ring system. Precisely the kind of targets the Stellar Reference Unit has proven unexpectedly well-suited to examining. That extended mission has already produced a genuinely remarkable string of discoveries in its own right, context that helps explain why scientists are treating this new Thebe image with such evident enthusiasm rather than simply filing it away as a minor curiosity. In 2021, during a close flyby of Ganymede, the largest moon in the entire solar system, Juno captured the first detailed close-up, images of that giant icy world in over 2 decades, and in the process detected direct evidence of magnetic field reconnection events occurring between Ganymede's own magnetic field and Jupiter's much larger surrounding magnetosphere. In 2022, Juno flew within just 220 miles of Europa's icy surface, using its microwave radiometer instrument to directly probe the actual thickness of the ice shell believed to cover Europa's suspected subsurface ocean, a genuinely important measurement for scientists evaluating that moon's potential to harbor conditions suitable for life. In late 2023 and into 2024, Juno conducted a series of historic close flybys of Io, the most volcanically active body known to exist anywhere in the solar system, capturing detailed thermal imagery of active lava flows and, in the process, documenting what researchers identified as the single largest volcanic eruption ever directly observed anywhere on that moon's famously violent surface. Even Jupiter itself, a planet that has now been under close, sustained scientific observation since 2016, continues to surprise the very scientists who have spent the entire mission studying it. Juno's onboard instruments have revealed that Jupiter's magnetic field is nothing like the comparatively simple, well-organized field surrounding Earth. Instead, it shows multiple distinct magnetic poles embedded within an unexpectedly complex tangled network, a structure considerably more convoluted in Jupiter's northern hemisphere than in its southern hemisphere, for reasons researchers are still actively working to fully understand. Juno's radio measurements have also revealed that Jupiter's atmosphere displays genuine structure extending hundreds of kilometers beneath its visible cloud deck, evidence that the planet's turbulent, colorful weather patterns are not merely a superficial surface phenomenon, but instead extend into its interior in ways that continue to challenge and refine existing models of how gas giant atmospheres actually behave. Taken together, this entire pattern reveals something genuinely important about how scientific discovery actually tends to work in practice, a detail that risks getting lost if this new Thebe image is treated simply as an isolated, standalone headline. Juno was designed from the outset with remarkable engineering flexibility, and a scientific team willing to creatively repurpose every available instrument, including a navigation camera never intended for anything beyond helping the spacecraft figure out which direction it happened to be facing. That willingness to look for scientific value in unexpected places has repeatedly paid off across the mission's now decade-long extended operation, uncovering shallow lightning nobody predicted, capturing the clearest available images of one of the faintest ring systems in the solar system, and now, in 2026, finally delivering humanity's first genuinely detailed look at a small, largely overlooked moon that has sat quietly at the edge of Jupiter's ring system since it was first spotted, as a faint, blurry dot back in 1979. It is worth being honest and precise about exactly what this new Thebe image does and does not represent, since that precision is exactly what separates a genuinely significant discovery from manufactured hype. This is not evidence of anything exotic or unexplained happening at Jupiter. It is not a mystery in the sense of contradicting established physics. What it genuinely represents is something scientifically valuable in its own right, the first real opportunity researchers have ever had to examine, in meaningful surface detail, one of the specific small moons directly responsible for feeding material into Jupiter's understudied ring system, using an instrument that was never originally intended to make this kind of observation possible at all. That is precisely the kind of incremental, patiently accumulated scientific progress that, across an entire mission, eventually adds up to a considerably more complete understanding of an entire planetary system, one unplanned, repurposed observation at a time. Juno remains, as of the middle of 2026, an active, functioning spacecraft, continuing its extended mission examining Jupiter's moons and rings in ever greater detail with every additional orbit it completes. Its stellar reference unit, a piece of hardware originally built for the comparatively mundane task of keeping the spacecraft properly oriented in space, has now, in its own quiet way, become one of the most unexpectedly productive scientific instruments currently operating anywhere in the outer solar system, repeatedly proving that some of the most genuinely stunning images and discoveries in modern planetary science do not always come from the instrument specifically designed for the job, but sometimes from clever, resourceful scientists finding brand new uses for tools nobody originally expected to matter this much. If you want to see what Juno's cameras capture next as the mission continues, exploring Jupiter's moons and rings, subscribe and turn on notifications, because this spacecraft keeps finding new ways to surprise the very scientists running it. And there's clearly more waiting to be discovered out there.